Good day. Welcome to another video on proof by mathematical induction. In this video, we will go through the process. First of all, proof by mathematical induction can be used to prove statements that asserts that P of n is true for all positive integer n, where P of n is a propositional function. And there are two main steps that are involved in the proof by mathematical induction. We have the basis step, where we show that P of 1 is true, and we have the inductive step, where we show that for all positive integers, k, if P of k is true, then P of k plus 1 is true. So once we can show those two steps, then of course, we would have concluded our proof. So let's look at an example. So we're going to use mathematical induction to show that 1 plus 2 plus 4 plus 5 plus 2n equal to n into n plus 1. And this, we are going to do it to show that it's true for all natural numbers. All right, so first of all, we're going to look at the basis step. So for the basis step, we're going to show that n equal to 1 is true. All right, so our basis step n equal 1 is true. Let's see if that's the case. We're going to show that n equal 1 is true. So we're going to take this part and this, and we're going to substitute 1 in there and see if both sides are the same. So we're going to say 2n equal to n into n plus 1. All right, so we're going to substitute 1 wherever we see n. So it's going to be 2 into 1 equal to 1 into 1 plus 1. That's 2 equal to 1 plus 1 is 2. So 1 times 2 is 2. So therefore, the basis step is true. So you can indicate here that it's true for n equal to 1. All right. All right. So our next step is our inductive step. All right. So I'm going to start that here. So our inductive step. All right. So we're going to show in the inductive step, we show that the condition P of k is true implies that P of k plus 1 is true. All right. So here we're going to say that P of k is true implies that P of k plus 1 is also true. So first of all, we're going to write this statement in terms of k. So we're going to have 1 plus 2 plus 4 plus 6 plus 2k, all right, is equal to k into k plus 1. So all I did, I replaced the n's with the k, all right? Good. So now we are going to show now that P of k plus 1 is true, all right? So I'm going to show P of k plus 1. So P of k plus 1 is going to be the next number in the series. So far, 1 plus 2 plus 4 plus 6 plus 2k, that's P of k. We're going to show P of k plus 1, and we're going to show that to be true. All right, now for P of k plus 1, so P of k plus 1 would be, all right, so we're going to show that P of k plus 1 holds. So we're going to have 1 plus 2 plus 4 plus 6 plus 2k. All right, so this is the last value when it was k. Now we're going to k plus 1. So we're going to go to the next number in the series, which is going to be plus 2 into k plus 1. So we're adding 1 to the k. So it's just, so the last number when it's P of k plus 1, it's going to be 2 into k plus 1. And we're going to add 1 to the k's on the right side as well. So if you look back here, we have k into k plus 1. So over here, we're going to have k plus 1. So you add 1 to this k, and we're going to add 1 to this k as well. So now I have k plus 1, but there was also a plus 1 there before, so we're going to have to put it back, plus 1. And now we have 1 plus 2 plus 4 plus 6 plus 2k plus 2 into k plus 1. That's equal to k plus 1 into k plus 2. All right, so 1 plus 1 is 2, so it's k plus 2 here. Now at this stage, what we're going to do now is we are going to replace the p of k with what is on the right side of p of k. So let's see. So if you notice up here, so this portion of the equation, that's all of this here, that's the p of k, right? And if you notice over here, when we had p of k, it's the same thing that we have here. So what is on the left side here is the same thing on the right side. So we're going to use what's on the right side to replace this here. So this is going to have us k into k plus 1. All right, so that's this part I'm replacing. I'm going to put back the plus 2 into k plus 1. All right, and that's going to be equal to k plus 1 into k plus 2. All right, now if you notice in these two brackets, we have the same thing, that's k plus 1. So all you need to do, if you remember from your quadratic equation class, you're just going to write down one of them. It's going to be k plus 1. I'm going to write what is outside, that's k plus 2. All right, so if we notice now both sides are looking the same, and so this proof is true, so we can just conclude that this is true for all natural numbers.